Nanotubes are cylindrical nanostructures, typically made of carbon, that are a few nanometers in diameter. They are essentially a sheet of a material, like graphene, rolled into a seamless tube. This unique structure gives them remarkable mechanical, electrical, and thermal properties. Composition. While the most common and well-known nanotubes are composed of carbon, referred to as carbon-nanotubes or CNTs, other materials can also form these structures. Carbon atoms in CNTs are arranged in a hexagonal lattice, similar to a sheet of graphite, graphene. Each carbon atom is bonded to 3 others, creating a strong and stable structure. Other materials that can be used to create nanotubes include boron nitride, silicon, and even DNA. Types. Nanotubes are primarily classified based on the number of layers, or walls, they have. Single-walled nanotubes, SWNTs. These consist of a single, seamless cylinder of rolled-up material. Their properties are highly dependent on how the graphene sheet is rolled, a characteristic known as chirality. This chirality determines whether the SWNT will behave like a metal or a semiconductor. Multi-walled nanotubes, MWNTs. MWNTs are composed of multiple concentric nanotubes nested within each other, similar to a set of Russian dolls. They are typically less expensive to produce than SWNTs and have a greater mechanical strength. And applications. The exceptional properties of nanotubes, particularly carbon nanotubes, make them useful in a wide range of applications across various industries. Electronics and computing. Their high electrical conductivity makes them ideal for use as a component in flexible electronics, transparent displays, and as a replacement for conventional copper wires in microchips. Materials science. Nanotubes are incredibly strong and lightweight. When added to other materials, like polymers or concrete, they create nanocomposites with enhanced strength, stiffness, and conductivity. This has applications in everything from sports equipment to aerospace components. Medicine and biomedicine. Nanotubes can function as tiny delivery vehicles for drugs, genes, and vaccines, targeting specific cells like those in tumors. They are also used in biosensors and for tissue engineering. Energy. Nanotubes' large surface area and high conductivity are valuable for energy storage. They are used in the development of more efficient batteries and supercapacitors. Environmental. Their large surface area and porous nature allow them to be used in water filters for removing pollutants and in gas storage applications. Aerospace. Nanotubes can be used to create lightweight and strong materials for spacecraft, as well as for thermal management and radiation shielding.